Hello, all. Thank you so much. Thank you so much for taking time to attend this session. On a personal note, I just want to start off with thanking Lily ma'am and Lata Selvi ma'am. They were my teachers, and we're very thankful for for the effort to put us where we are at this point in time. So, thank you so much, ma'am. And so next 30 minutes, 45 minutes, we'll just go through cloud security. I know some of my initial slides are going to overlap with what you already heard. But the intent is over here is to show you how attacks are made at the application level, a simple programming level, what we used to do before and what we are not doing today, which is causing some of those issues. And we can actually go through a hacking environment, a system, a use case that happened in Capital One and figure out how that was happening. And also we'll show you some cloud components that will enable you to defend against all these attacks. I just have AWS. I'm sure that you should be able to mix and match with the other cloud providers. The services are going to be the same. We will also take questions in between. If anybody have any questions, just I'll stop after fifth or sixth slide, and then you can stop. You can ask your questions, or you can always message. Uh, so let's just go on. So I basically work on cloud environments. My job is to migrate applications and from on-prem into cloud. And of course, the key is to automate everything, not just migrating it manually. So the term that everybody uses is DevSecOps, which basically means that your application and then your operation and your security are getting automated, and no manual intervention is allowed in that space. So that's pretty much what I do. In the area of data, like if you're using stock market apps like ShareCan or something, all the data that come up on your screen, I do something similar to that. And then I do also work with AWS and Azure. As I said, the agenda is we're going to look at where some of those big companies lost their game and what options did they have before losing it and what they ended up in doing after it. So you have a lot of checks. You just have so many security personnel. You can't just keep in every door at your home, right? You can just keep a couple of them. So just identifying where to keep them. That's the key. So that's going to be the agenda. In the cloud environment, when you try to move your application to the cloud, what are the key areas where you want to do your security checks, and what are those security checks are going to be? That's exactly the agenda going to be. So we stand today in an environment where cloud is not an option. That's where everybody is going. That's the faster to market strategy. So if somebody is going to stay, like for example, banks in Europe used to have a lot of security, so they never even allowed offshoring their jobs to India because they're so worried about the data. So even those companies started doing GPDR, which is the European version of data protection law. They brought the law so they can still use the cloud capabilities. So people are finding ways on which they can use cloud. They are not ignoring it. Primarily because the cost optimization and the whole thing of giving away the whole baggage of security to another vendor and just handling your application portion of it, which is really good. So you always have somebody to blame, not just you when an event happens. So having said that, the most attacks that we have seen at this point in time have never been cloud vendor attacks. For instance, let's say AWS or Azure, they're providing you the infrastructure. There has not been a scenario where there was a issue with the AWS or Azure or Google or whoever it may be, Alibaba. They did something which eventually caused an attack. So it has always been, at least the trend could change. Obviously, somebody could even enter the data center, do something. But at present, the trend suggests that if you are a user of the cloud infrastructure, you are the primary reason why the vulnerability is in place. You are not doing what you have to do to protect your own applications. So the onus is more on the user than the vendor. So this presentation is going to take you through that path to show you what some users actually did that caused some issues that eventually faced. Cloud vendor on their side have also started doing more flexibility. They start giving a lot of flexibility in terms of shared responsibility model, where they said, okay, you take care of this portion, I'll take care of this portion. So we both collectively can manage your security issues, right? And they have a lot of services that we're going to go after in the future slides that they allow you to, while you to prevent the attack, and even if the attack happens, how you get alerted and how you respond to it, right? So they started giving a lot of services around that space. Now, I'm sure that this slide is something that you probably saw before. And what we're going to look at is the capital one out there in the top, which is data exposed to 6 million Canadian SSNs and 100 million American SSNs. To actually give you a perspective, 100 million Americans is almost 1/3 of America. So there's probably, or 1/4 of America, there's just 400 million people who may have SSNs. And of course, people who have credit cards are definitely not 400 million, maybe 200 million. So half of them have already been exposed. So if I get hold of that SSN number, that's like getting hold of our Aadhaar card number. I can pretty much use that to open a bank account, apply a loan, do whatever I want to do. But just look at this trend, right? So we all think that these are only things that happened up until December. So if you are downloading applications in your mobile phones, if you are using Facebook-like applications, you probably are getting emails of data breach, but all those are going into your spam. So every application at some level, small applications, some level, like health monitors, like I want to go for a run, I want to find how many miles I've done, how many calories. When you do that, you do sign up with your Google, and then that's how you get access to your application. So what happens is you think that you're using that application, but then you already signed up in Google, so your whole profile has been transferred right now. So they get view of what you're doing, when you're doing, all those informations, right? Now, those were also breached, but just that they didn't flash in your screen, or that wasn't your top of your news. So there's so many apps that has gone into data breach. So IBM is saying of 2019 breach report that they provided, per record, cost of lost record per record is $150, right? Think about at the average rate on the reported rates, right? Reported rates of company data. It's about 65 trillion data has been lost or breached. So you get those numbers, $150. So the $150 is obviously not at 65 million. 150 is with whoever paid to retrieve the data. There are companies who just didn't bother about the data, just left around. But in real cost, if you just multiply 65 trillion into 150, it just goes sky. So you have about 4 million per data breach. These are numbers that are recorded by few countries and few applications. So there's a lot more than what you see in the screen. Now, what we saw is what's the impact, right? Now, let's just look at how do we, as a user, allow this to happen, right? Simple OAuth service that we all use. We all been using it for 2 years or 3 years now, where we don't want to go in and log into every application. We just wanted a button where we can click so somebody else authenticates and gets us into that application. One such, if you had a GoFundMe account or you had anything like health related apps, everything had access. It'll either ask you for your Apple ID or a Google ID or a Facebook ID. So they actually, the Facebook or the Google actually have the OAuth server. So that's where your authentication happens. Your application, you're trying to log in, is going to go and say, okay, you know what, this guy is signing in, this is his credentials, that's what he entered. Is it right or not? So they're going to give you an authentication key. Now use the key for all your transaction with that application. Now there are 4 scenarios. This is something you do daily. I'm sure each one of us do at least have one mobile app in our mobile phone which does this. So just look at what you're doing today, right? You could end up in just downloading an application, assuming it's a trusted in the app space, like Apple Market Space or somewhere, right? And then just downloading that application, which happens to be your intruder, which is stealing your data. So that's one option. You're doing it yourself. The second option is you just right now I had this issue. I wasn't able to share my screen with using Chrome browser, right? Now what I did was I gave all access to Chrome browser in my machine. So because I want this slide to be running, right? But what I really did was, if somebody gets access to my Chrome browser, they pretty much can access everything in my machine. They can even access my camera. They can even access my data. So you downloaded an application and it just pops up and saying, okay, can I have access to your camera? Can I have your access to your microphone? Can I have access to your profile? We give okay, because all those comes at the first flash screens, right? You were so interested to see your first screen. So you tend to say, okay, but eventually what you're doing is you potentially gave the application access to all the data that you really didn't want to do. Now, the third per se is application just got in, slowly start, and then it was not the actual source of the malware, but let's say that application got affected. And eventually, every application that depended on this one, like for an example, you have a health app, and that health app is going to listen to Apple. If you had an Apple phone, there is a health application in Apple phone. So it's going to listen to that health application to gather data. Now, if this health app gets compromised, you are also compromising the Apple Health. So the application slowly starts spreading all the issues that it has across all the other applications that are in that device. Now, the fourth is the most common one. We all do, we keep doing, we will always do, I guess, as long as things are free. So like Facebook, where because it's free, we sell our data knowingly, unknowingly, and we can complain about it. These are 4 items. If you look at each one of these items and then think about, you will definitely fit into one of these boxes. Now, this is something under your control on a day-to-day activities. But look at an enterprise, right? What kind of an issue an enterprise would have in securing their servers, right? Now, Capital One breach was one of the top in-line news late last year or early this year. I guess late last year. So what really happened was totally the most simplest form of retrieving data. Capital One provides credit cards, which means it has loan accounts, credit cards, and it's like our HDFC Bank. It stores all our information, like our Aadhaar card, everybody's SSN number. So what did they do wrong, right? All that they did was, if you look at cloud, there is something called roles, right? So as a user, you could either access a service or a server, right? By giving your username and password, or you could always use a role in our education environments when we have labs. So each one of us used to have username and password, and there used to be an administrator username and password, and we used to have an administrator group where we add all these people into it. Now, this role is nothing but the administrator group. All the users get added to it. Now, in the cloud environment, this administrator group by itself will have credentials other than the user credentials. So if somebody gets access to this credentials, they don't have to know every user under that group. They don't have to know their credentials. They can just do whatever they want to do. So that concept is basically called roles. So if you actually, I'm showing you an AWS example. So I just have two. So let's say AWS support role, for instance, right? So this defines your permissions or what this role actually can do. So we just have a slowness in internet. Yeah. So this role that I've showed you, so all these are services. For an example, backup service, budgeting service, API gateway is the API service. And then CloudFront is the CDN service. So a lot of services, think about a cloud as in, think about your desktop, right? So your desktop has a Microsoft Office on it. You have an Outlook on it. You have different applications, right? Now, as a user, when you log in, you don't get access to everything. You just have access to certain things, right? Likewise, this role is defined with having certain things. Now, what really happened was this guy out here, he used a virtual private network, which is free. And he used an identity masker. It's called the Onion router, which basically masks all your IP information and everything. What he did was he used SSRF. You look at SSRF right after this example. I'll show you what it really means. Is you try to use it and try to get the role that I showed you, just the role name, right? Now, once you got the role name, he used the same SSRF to go get the role credentials. Now, the role, once he gets the role credentials, he pretty much have access to the whole server now. So all that he had to do was, it's not the key. He has to know the role name, and then he can log in into that box. Now, once he gets logged into the box, now all the data are stored in folders like S3. It's called S3 buckets in AWS. It's stored in data. So what really happened was he got access to all the data in those buckets. And then he actually did not even realize those were SSN. So he just tried to go against all the buckets. He got all the buckets. And then 2 weeks, he was in that server. There were alerts. Nobody cared about it. He grabbed all the data. Now, there are two issues that you can see here. Out of all this, somebody using iPredator, somebody using Tor and breaking in, there's a programming issue here. There's a firewall issue here. Above that, actually, this instance, this was a web server. And this instance was not supposed to have all the access or all the data that's in this buckets, which are these folders. All that this instance was supposed to do was to check the guy coming in is right or wrong. If he was right or wrong, if it was an authenticated user, it was supposed to go to the backend. But on a configuration mistake, somebody went up and gave all access to this role for all this folder and buckets. So which eventually made sure was one of the biggest blunders that they did, and the attacker had all the access to the data. Now let's just quickly look up what SSRF is, right? So let's say you have you're trying to go into some, let's say, Flipkart.com, right? And then you're trying to access Flipkart.com, and then you are seeing the browser URL, and then it does a lot of transaction. At some point in time, you figure out something weird happening, like something a specific a browser call actually appended a URL here, which basically means that when you did enter in the browser, it had to go to this URL and then just append your product ID, store ID, and then return back the actual order information, right? Now, what you see here is this port is so visible. So now everybody knew which port the server is listening to, right? Because of 66,000 ports, it could be listening to something else, but then we literally exposed 80,000, right? Now, what he also knew was what was the server name? This is the whole server name out here. So what he pretty much could have done with SSRF is he's going to run the same API and then type HTTP localhost/admin. And the key thing you have to look at is HTTP. It's not even HTTPS. Right? If it's HTTPS, there's no problem. Nobody could have done anything much about it. Right? Now, when he did that, what he basically did was he went and hit the Apache of the web server. And then this basically returns the whole IP address, all the information of this web server, what role it's using, where is this instance, and what's the host name, what the port it's listening to, all information. Now, the attacker got hold of all this information, which was the key thing, which we discussed about role. And then he got this role, and that's how he got all the other accesses. Now, this is SSRF, but there's also other things like we were discussing about SQL injection. Right? Think about, there used to be times that C, when we wrote our programs in C, we always have to declare our data types. And it's so funny to realize that some point in time we thought, okay, hell, I don't want to do that. I mean, that's why I use something else like Python or something else, right? Now, if somebody wrote a program like this, right, he fetches, you're going into your browser, you enter your username, right? He fetches the username, right? He just stores. He didn't check whether it's a string, whether it's alpha, whatever usual checks that we do on a username, right? So what he did was he didn't even check whether it's valid or not. He tries to take this user ID and tries to go inject this. So this is his 2 lines of program right now. So what happens in this situation? If a user inputs this one, right, like this on that user box, okay, eventually what happens, he's trying to append it to user ID. So it says select star from user where user ID is 105, semicolon, drop table supplies, right, which basically deletes the whole table. So this is pretty much a SQL injection, right? Now this happens is because when you write a program, you tend to not check the actual instance of a variable that gets passed. So you just assume that the user will always going to pass a valid username. The max that people check is probably if the username exists in the database. Even if they do that in this situation, they could have saved some time, but that didn't happen. So these are pretty much areas where as a user, we do a lot of mistakes in our programming, which eventually gets us into the situation. Now, before I actually move on to the next topic, I just want to stop and see if anybody has any questions about it. Okay, I guess no. So I'll move on. So the next thing that I wanted to so the next thing that we're going to look at is what's different in cloud. We know all these things are happening. What's different in cloud? So to know what is different in cloud, you have to look at 3 models of cloud that they provide. First one is software as a service, which is the most easiest one, like your Microsoft 365, where you don't install that software in your desktop. You just use the cloud version of the software. So all that you're worried about here is your application. If you're using Microsoft Outlook 365, all that you're worried about is your username and password. Keep it secure. That's the only thing you're worried about. You're not worried about anything else. PaaS is platform as service. Like for an example, you own the application, but you don't own the infrastructure. You are actually giving your application, let's say for an example, Flipkart.com, right? That's your application. And then you are using a PaaS provider like Pivotal Cloud, or even in sense at some level AWS or Azure, and then using only their technologies, like their messaging technologies, the integration boards. For an example, let's say you have Flipkart.com, you have an order status, and you have another table which is storing all the information about order, right? Now, this table has to call the order, so all the messages will go into a queue. And generally, queues are, you could have your own queue, which means that you're going to have your own server. You're going to host it. You're going to you're going to work on to secure it, you're going to do all those stuff. But here, what you're saying is, no, I don't have anything. I just have my code. And then I have my tables down here. So you give me the database, you give me the messaging structure, you give me the app development, everything, right? So that's PaaS. So the last thing is infrastructure. Infrastructure in the sense that I'm moving the whole application. I don't own any servers. I don't own any data centers. I don't own any real estate. So I'm moving the whole data center into IaaS. So these are three models. And how do you envision these three models? As I first said, SaaS, you just worried about your own username and password. PaaS, you are using all the software that the cloud provider is providing to you. So when you're using all the software the cloud provider is providing to you, you should also know the cloud provider does not have access to your data. For an example, you have a secure data, right? Now you're not storing here, you're actually storing in your cloud provider's service, right? So he can always, it's his data center, he can always have access to the data. So how do you secure it? So that's where the key and encryption and all those things comes in. But even in this level, you're not worried about the real estate or your server security or anything. You're just worried about your data security, your application security. Infrastructure as service is the whole lot game. You're worried about everything. You're using somebody else's servers. You don't own the real estate. They could potentially have access to everything. So you were more worried about, it's not your data center, somebody else's data center. What if somebody bombs the data center? So you're worried about it. What if that data center is going to have multiple companies storing their data? So you don't want another competitor of yours to steal your data. So how do you safeguard that? You have a lot of other questions that you ask when it comes to infrastructure as service. Now, with all this in place, we don't think we're just starting now. So I guess we went through this before, but then to just bring your attention into three topics of cloud security. Infrastructure security, which is the last one we talked about, the infrastructure as service, which is infrastructure security involves all these three, but then specifically infra as service. Governance and compliance are more like a PaaS concept. Governance or compliance are more like controlling how your application is going to behave. Infra-security is more like controlling how the external force are going to access your application. So we will go dig into each of these topics and figure out how do we secure our data based on these. So we started off saying, I guess it was a slide 2 or something. We started saying, how do we handle shared responsibility model? What is shared responsibility model? I was saying the cloud vendors are now providing flexibility. This is pretty much what a shared responsibility model is. It's basically saying, if you're using on-prem, which means that I don't use cloud, right? I'm on-prem. In that sense, all the responsibility is on you, right? Now, if you are using SaaS, which is the first column of what you see here, which is software as service, what are you worried about? The responsibility of the customer is too small because he's just worried about his data, his devices, and his accounts. He's not worried about physical data center. He's not worried about physical network. He's not worried about physical host, operating system, network controls, anything. So what it really means is I could have my application running on a server of, let's say, a cloud provider, right? And then the server gets breached, it's his problem. It's not my problem. But if I gave my username and password, or if I had a system, which I was showing you before, how people snoop into your code, which is, it's not using HTTPS. That's my problem. That's the top end of the problem we were discussing before. So SaaS is that kind of a model. Now PaaS extends your responsibility as a customer towards your network controls. Because now you start using his application services. Now, when you start using his application services, you sure know who should have access to it, because obviously not everybody will have access to it. So you start adding in who will have network controls, who will have applications, who will have identity infrastructure response, because you're gonna maintain your auth and everything. Your whole user base is going to go into cloud to use your application. And then they're going to interface with the cloud providers, services that they provide. Now, that means the extension is still network control. IaaS is pretty much means the only one more item that you have to add to your list is operating system. So when you say operating system, so let's say we are running this with a Mac OS right now. So a new patch of Mac OS comes in. It's not the responsibility of the vendor like AWS or Azure to actually get you on speed and then get all this patches installed, because your application will be working with, let's say, Mac 18 or Windows 10. You don't want your application server to go to Windows 360 or something like that, because your application is tested for certain operating systems. So you still don't want to, even if it's Java, you still don't want to just move across, right? So in that sense, you are responsible for the operating system patches. You have to just make sure. But rest all, like physical host and network and data center, are pretty much handled by the vendor. Now, this is shared responsibility across the board for every vendor, cloud vendor, including AWS, Azure, or Alibaba. Now, jumping into the what we discussed before, right? How do you secure your application, right? With all the issues that we were discussing before. Now, let's just go back. Let's be on this slide and let's just go back and compare the other slide of Capital One breach. Now, as I said, the internal calls that they're doing was HTTP, which is very unusual for a bank. When I say internal, it's everybody reaches. They use HTTPS to reach to Capital One, but then between the backends, they were using HTTP. But HTTPS is the only way. HTTP is not allowed. It's a secured way. HTTPS pretty much is like a secured web server. So you connect to a web server and the web server gives you a certificate. And then you start using the certificate to communicate for your future communication with the web server, right? So that's how HTTPS works. So that's the way to go, including internal calls. The other way, one more thing is when we do internal calls, like for an example, we use loopback addresses like 127.0.0.1, which means the local host. Having local host or 127.0.0.0.1 as an incoming request is straight no. So we should be able to deal with them at the firewall level. It's straight no. You should never allow them to come in. So in case of registered customers, for example, let's say you have an application. Let's say we have an application for our college, right? And we know the users, right? The geolocation of the user for a college is going to be within that country, right? They're going to use that application within the country, right? You could restrict users also in many ways. One is using geolocation. So one is using geolocations. The other one is using, you can just look at the subnets, the whole IP address range, and then say, okay, allow communication within the IP address range. Or the best possible is you could give their certificate, and you could also take this. You can give your certificate, and they can give their certificate, and you can do two-way authentication, which basically means that when you hit enter on your browser, you are sending your certificate. And then the server will validate, okay, whether your certificate is valid or not. And then he will again send back a certificate to you, and then you will validate whether it's valid or not. And that's when the communication channel gets it. So, but the whole discussion about two-way SSL or IP, so whitelisting and all those concepts are only available when you know who is going to connect to your application. So it's not going to work in case of Google.com or HCFC Bank or something like that. The third thing is the data encryption, right? So anywhere, anything you do, obviously it has to be secure. In transit, in rest. In transit is like when you transfer data from one bucket or one location to the other location. And on rest is when the data actually stays on the folder or on the bucket, right? So you should have essentially have encryption keys locking them in. Now, a fourth thing is centralized logging. Whatever happens across the board, you should always log them. So, and then you should have alerts triggering. So, for instance, whatever I do, this is a sample account, so you're probably not going to see much information out here. But if you look at the way that the whole orchestration works, like let's say there are multiple ways. Infrastructure logging, like you do something like you bring a load balancer, you actually crack open an EC2 instance or something like that. Everything at the in network level gets logged in AWS case. It gets logged in something called CloudTrail. Now you could always what you can do is you can connect an security alarm. So let's say you don't want somebody to access a EC2 instance or a server, for instance, or you don't want somebody to create a security group. So what you can always do is that will create an event here. From here, you could actually use something called CloudWatch logs, which basically sets an alarm of when this event happens, this gets triggered, and then you can ask it to send an email to your personal, the company email ID or something. So you can always, so these events are right now. So think about world before cloud, right? These events are somebody has to do somewhere. These were different software. So now everything is in one dashboard. So you can pick them and choose them as per your need. So you could always look at some metrics. So you should always look up some metrics or events that happen, and then you can always send an email back to that location, back to you or your support group, and then they can respond back. I'm sorry, somebody. So this, excuse me, just 1 minute. Okay, so some reason this is slow. Yeah. Oh, here you go. Okay, so you could specify, okay, these are my services, these are my services, and then if anybody logs into the service, give me a message, right? So these are centralized logging methods. So your application, for example, if your application is returning 500s or 400s, you can always trigger an email back to you, so you can respond to them, assuming, even if it's a valid error, you should know why it's happening. Now, typically, these are the three things that in fact, these are the models that every company has deployed, at least for past few years. They have layering authentication right now, so which basically means that, as I said, you have front-end servers and back-end servers. So when a user comes in at the front-end server, he gets authenticated first. So you don't go all the way to your application and then get access to the data like what you saw in the other case, right? So you have a front end, and that front end is basically going to say, okay, you're a valid user or not valid user, and throw you back if you're not valid, right? And then if it's a valid connection, only then it starts moving in. For in case your certificates, two-way SSL certificates that we discussed before, the certificate validation happens at the first server, your web server, validates your user authentication, certificate authentication, and everything, and then passes on. If it gets authorized, it passes on the request to the backend. So DMZ architecture is one way that everybody is going in right now. The other one is, for an example that we were discussing about, how do we stop somebody doing something like this? Like the example that we had is this, right?
Venkatesh,
Yeah. Yes, ma'am.
sorry for the interference. Actually,
Sure.
12 o'clock we have to join for the inauguration function.
Sure, no problem, ma'am.
Okay.
Yeah, sure. Thanks. Is it 12? Can you stop now, or?
Okay, just give some conclusion.
Okay,
Some
sure,
5 minutes
sure.
will take. Give some conclusion.
Okay, sure, ma'am, sure.
Okay.
So I just want to complete this thought that we went through, right? So there are services like CDNs, Akamais, which is going to front end your web application, which is going to filter requests that we saw here, where somebody is entering the whole URL, like for an example, localhost. So that the request won't even come into your DMC, so it'll stop right off the bat at the top layer. So and then obviously penetration, security audits, vulnerability. These are something that all of us know that people have been doing for a long time. I do have a few slides, but based on the time, these are slides to explain you what you can do at what level in cloud for data protection. We talks about encryption on rest that we discussed. So that really helps you. So basically, there's just 2 points that I want to say. Never trust client data. Always treat it as untrusted. And the least privilege access. It's simple. Don't give the whole lot privilege the way that I gave Chrome today. So just give what it requires. These two on the enterprise level would save you a lot of issues, especially, or you don't want somebody to open up the server, the security group to outside world. So you want to restrict them. That's all pretty much I have, I guess. Thank you so much for your time. If you have any questions, drop me an email on this slide. I hope this slide will get shared to you. Thank you so much for your time. Thank you, ma'am. To you.
Thank you, Venkatesh.
Sure, ma'am.
If any queries are there, please ask. Otherwise, please join in the Facebook link. Afternoon session starts at 2:30.
Hello. Ma'am, what about ID? How to put the ID for this?
Sir, actually, we'll sort out that, sir. For time being, you just write your name in the feedback. Just fill the name. We'll sort out everything in the afternoon session. We'll sort out.
Okay. Thank you, ma'am. Okay.
Okay, sir. Okay. Kindly all of you join for the inaugural function in the Facebook link that is actually posted. For afternoon sessions, you have to join at 2:30.
Hello.
Yes, sir. Yes.
Hello. I have a question for Venkatesh, sir.
Venkatesh, are you there? Oh, no. He has gone, I hope so. So anyhow, I'll ask, sir. I'll just get the reply and put it in the chat.
Okay.
Just, what is your question, sir?
Is there any difference in HTTP and HTTPS?
Link clerk. Okay. Yes. Is there any, sir, what is your question? Is there any difference between?
Difference between HTTP and HTTPS?
Sir, he is coming in. Just a minute, sir. He is coming in.
Okay.
Yeah, can you hear me, man?
Yes.
Venkatesh, sir?
Yes, sir.
Yes, sir. Your examples are very excellent, sir. Day-to-day examples and what we see is very good, sir.
Thank you, sir.
I have a question regarding one thing, sir. Is there any difference between HTTP and HTTPS? Is it HTTPS is more secured?
So HTTP, so both are under TCP, right? And then there is a SSL encryption. So for an example, let's assume that I communicate to you and you don't know who I am, and I just know you, right? You are the person who's going to give me the data. Now I communicate to you, you're just giving me the data. So you just responded back. Now that's HTTP. Now let's say I communicate to you and you have a certificate, which is a secured certificate. You pass that certificate to me, and then our transaction always happen using the certificate. You validate. Every request I do, I attach the certificate and send it to you, right? So the HTTPS is more like SSL encryption added to it. So your communication, no one else who does not have that certificate can ever come into our communication. So that's the difference between HTTP and HTTPS.
Okay, okay. Thank you, sir. Thank you.
Sure, sir.
नोटपैड में नहीं ना
How do we join from this Facebook link, man?
पेंट में चलता है ये पेंट में चलता है
डेस्कटॉप ज्यादा कन्वीनियंट रहता है इन
पेंट में चलता है पेंट में चलेगा 100% चलेगा 100% चलेगा
Sir.
Yes, sir.
Yeah, this is Raja Mama sir from St. Joseph College of Engineering. So can you
Yes,
share your presentation to my mail ID so that I can share to all the participants?
Sure, definitely, sir.
Okay, sir. Sir, can I send my mail ID, sir, through the chat box?
Yeah, sure, sure.
Okay, sir. Thank you, sir.
Thank you, sir.
No problem.
Okay, sir.
Yes, sir.
Yeah, another one question, sir.
Yeah.
At any point of time, can we reach the 0% attacks? There will be no attacks anywhere in the world. What do you think, sir?
So it just depends on how do you define an attack, right? So attack in the sense that we not reading the agreement that pops up when you open an application and then giving our own data. That's also an attack in technical terms, but then those are going to happen. But then there's never, for an example, this Akamai CDN that we were talking about. We had a attack, DDoS attack. Like DDoS attack is people keep sending. Let's say I have an application, and then I just built the application for 500 users, and then somebody just gets my application endpoint. They just bombard it with 1,000 users with wrong credentials, right? But just because of sheer amount of traffic that just came into my application fails, right? These are ways that people can get your application down. So this is how it was. And then they brought a new concept called WAF, Web Application Firewall, and CDN inbuilt at the top. Now they try to stop DDoS at that level. So attacks are going to happen. New technologies are going to happen. Otherwise, we won't have a job, right? At least.
नहीं तो ठीक है फिर दिखेगा ना स्क्रीन शेयर करो
Okay, thank you, sir.
Sure, sir. Thank you.
ये पहला वाला समझ गया अभी आपको अभी देखता ना मैं ट्राई करता हाँ
पहले ये सारा PDF फाइल देते थे तो मैं प्रिंट मार लेता था अब ये इन्होंने फोटो फाइल दी है कैसा के ईमेल में सेंड कर हाँ ईमेल में सेंड कर क्या
Is there any more queries? Shall we break for the inaugural function? We'll rejoin again at 2:30 p.m.
Madam, without ID, the feedback and attendance has not been submitted.
Sir, no problem, sir. We'll sort out everything by today evening 4 o'clock.
Because without ID, it is not submitting the form. So we have not filled it out. Okay. So we'll joining over there.
Okay, okay. At 4 o'clock, we'll sort out everything, sir. By today, we'll be finishing off.
Okay, thank you, ma'am.
Okay, no problem, sir.
Session 2
Please
feedback
have
link, madam.
that also we'll share it again, sir.
Okay, madam.
Share it again in the afternoon.
Okay, madam.
Okay, okay, sir.
2:30.
Okay, thank you all.
2:30.
Okay, 2:30, sir. Now you have to join in inaugural function.
Okay, okay.
Thank you all. Thank you, Venkatesh.
How do we join in that inaugural function, ma'am?
Sir, yes.
How do we join in that inaugural function? I
Yes,
tried
yes,
to
yes,
click on
yes.
that Facebook link, but unable to
Yes, sir.
join.
Yes, sir. Yes. You have to join in the inaugural function.
Through the Facebook link.
Yes.
But I'm just getting a picture of GTU. I don't get anything else. Right? It's going to start or wait?
Sir, actually, even I am going to join, sir, because still I am in this meeting.
Okay, thank you. Thank you.
Okay, thank you, sir. Thank you all. Shall we close now?
சரி அது இதுல ஃபேஸ்புக்ல நீ முதல்ல ஜாயின் பண்ணு அப்படியா அப்படியே ஃபர்ஸ்ட்